So, continuing our discussion of sampling methods, a systematic sample is often used in manufacturing environments where you really have complete control, complete access to the entire population. So, in this scenario, the manufacturer has access to every item produced, but only wants to test a sample. That's going to minimize costs, and so that the remaining products can still be sold. So when using this method, it's important to vary the first item picked. That's the randomization part, right? For example, if you always start with the first item produced, then you'll never test items from near the end of the batch. So you might miss a problem like overheating that only occurs near the end of a production run. And similarly, if you always start your test with the 20th item, then you might miss a problem that only occurs in the early part of a run, like the machines not being allowed to warm up properly. As the name implies here, this method is based on the convenience of the researcher rather than any randomization. It's often used as a fallback when no other method fits the needs of the researcher and the access that they have to the population. Its ease of use makes it possible to get quick results cost effectively, but there's also going to be a really high probability that you have at least some level of a lack of representation. In other words, your sample isn't going to be representative of the entire population. So at this point, we've talked about a variety of common sampling methods used by researchers and statisticians. So in the last lecture in this sequence, we're going to discuss some invalid sampling methods. So you'll have an idea of the things that should be avoided when you're trying to develop some kind of statistical research project.